Well, hey friends, you know, it is a beautiful day here in this neighborhood. I'd really like to show you something. Do you know what this is? This is a small 3D printer that I have, and there's nothing printing on it, but I'd like to bring you in close and show you exactly what it does. So that is pretty powerful, right? We've made a little boat. That's pretty cool, don't you think? We can use 3D printing technology to make things, objects, new parts, new pieces. But what if we could copy an already existing object by using the 3D printer? What if we could somehow scan an already existing object, like this pencil or this ruler, and then print a copy on the 3D printer all in one step? Wouldn't that be interesting? Well, it turns out that there is powerful technology that we can use to do that, and that's something that I've been working on and I'd like to share with you. So this is the beginning of what's called the Photogrammetry Project. And what's going to happen is any object that we want to copy, we're going to put on the platform. Then the platform is going to spin on its own. And while that's happening, the camera is going to move up and down and take pictures of the object. Then that information will be sent to the printer, and it will print us a copy of whatever object is on the platform. So you may be asking yourself, how are we going to get our green table to spin? Well, we're going to use a very powerful device called a motor. Lots of the things that you use every day have motors in them, like your parents' car, or the ceiling fan, or the dryer. This is a motor, and I want you to see if you can tell me what it does. So I've got it plugged in, and I'm going to turn on the switch, and then it's going to do something, and you're going to see exactly what motors do. So that's what motors do. When you turn them on, they spin. Got a little bit of mail here. It's a letter from our friends. Look at that. It's from Ohm.
Hey, Mr. Warden. How are you doing? Look at these robot arms I made. Let me show you how they work. I control the arms using my legs. I do this by using these little red things called potentiometers and these little black things called motors. I put potentiometers on each of the joints of my legs and the motors on each of the joints of my arms. Let me show you how they work in action. When I move my leg up and down, the shoulder moves up and down. When I move my knee up and down, the elbow is supposed to move up and down. And when I move my foot back and forth, you can see the hand opens and closes. As you can see, they don't work perfectly yet, but I'm still working on them. Bye, Mr. Warden. Have a great day, and see you next time.
Wow, that is awesome. I'm very proud of you, but more importantly, I hope that you're proud of you, because that is awesome stuff. Keep working at it, keep making awesome things. Thank you so much for wanting to share your project with us. And if you're at home and you would like to share your project with everybody, you can send me a short video to the email address at the bottom of the screen right there. So I've got a special motor here called a step motor, and I'm going to bring you in here and show you what it does. But I want you to remember the big blue motor. What happened to it when we turned it on? It spun really fast. But what if I needed a motor that turns much, much slower? How could I do that? Well, there's a couple things I can do. The first thing I'm going to show you is this motor that I have here. This is a motor shaft. This is the actual motor, and this is what spins. Okay, I've got a power supply here, which this basically acts like I'm plugging it in. And as you can see, when I turn that on, this little shaft began to spin. Do you see that? Let me bring you in a little bit more. Okay, you can see this little guy spinning. Now, one of the things that I can do is I can turn up the electricity on the power supply, and it will spin faster. And so if I needed to turn my motor much slower, I could give it less electricity. I could give it, say, 3 volts instead of 6 or 9 or 12. The other thing I could do to slow my motor down is build a whole separate device called a gear ratio. And as you can see here, I've attached my blue motor to a device called a gear ratio. And now when I turn this motor on, you're going to see what happens. This gear right here, this very small green gear, is going to turn just as fast as the motor did. But because of all these gears that I have in the middle, this gear is going to spin much slower. Let's try. Do you see how much slower this gear turns? See, if I needed to have a motor spin much, much slower, one of the things I could do is I could build a gear reduction like this and have it so the part that needs to spin could be at the end of my gear reduction, just like this one. So I could have a powerful motor as the input, and it would have a slow output. The third thing I can do is use a stepper motor. It doesn't spin continuously like this motor or the blue motor. In fact, it moves in steps, step motor. So I'm going to get the 3D printer set up, and I'm going to show you how it works, because the 3D printer uses step motors almost exclusively. And it's really interesting and really powerful to see why it works that way. Before we move on, I'd like to show you one more thing. This is an engineering notebook that I've used for the past year or so. This is a notebook that has grid paper and graph paper, and it has all sorts of notes in it about my thoughts and my feelings and my projects and all of the things that I think and all the things that I want to do. And if you're interested in making things or fixing things, I would like you to try to find yourself a notebook that you can write in. It doesn't have to be fancy, it doesn't have to be even put together. It can be a collection of paper, it can be post-it notes. Find some place where you can write down your ideas. Because that's important. It's important for us to be able to write down our thoughts and feelings so that we can go back later and think about them a little bit more. That's why I write stuff down, and I think it's important to write stuff down. So I've got the 3D printer running again. I've got my step motor over here that we're going to use, and I've got the 3D printer set up, and I want you to see there are 3 step motors that let the 3D printer do its work. There's one up here right at the top of the screen. This allows the plastic material to go in and out. There is a stepper motor right here. This allows the printing head to move back and forth along this rail. And there's another step motor underneath this platform right here, and that allows this whole assembly here to move up and down. Very important. So I've got another little device here that's very much like a 3D printer, except it's the opposite. A 3D printer is additive. It adds material until you have the part that you need. But this little device here actually subtracts material. It carves material using this little head right here. There's a small bit in here where my finger is, and that allows us to carve this material. So what I'm going to do is I'm going to carve some material away from this little block. I'm using the controls here. Can you see that? Let me zoom you in. And I've made a little hole, right? So instead of a 3D printer which adds material, this guy, this milling machine, subtracts material. And you can imagine how powerful that might be. Just like the 3D printer, there's a motor right here, a step motor. Just like the 3D printer, there's a step motor right here, and that allows the head to move up and down in step. There's a motor on the back side here that allows the entire carriage to move left and right. And there's a step motor back here, and that allows the bed to move forwards and backwards. So the power of these guys, so the power of the step motor right here is that we can use this to move all of these things in discrete little steps. Because you can imagine that if these motors were all turned on so they spun continuously, you can understand that that might be a little bit of a problem as this carriage moves off the table. That could be a problem. So instead, the step motor allows us to move only little bits at a time, precisely how we need them, so that we can do very powerful and interesting things. And that's what we're going to look at the rest of today's episode. Do you have magnets at home on your refrigerator? I have some magnets right here. You know, they're very strange magnets. How do you think they work? I often think about how magnets work because it's all very strange, isn't it? How do magnets stick to things without any glue or tape? Something to think about. This is a circuit board. This is also a computer, but bear with me. This is a computer. Lots of the things that we use every day use computers, use circuit boards. The power of the circuit board is that it's going to allow us to tell the stepper motor inside this platform how much to spin and where to spin. And here's how that's going to happen. I've actually built a very tiny, very simple computer here so I could show you how this is going to work. This small computer I built has 4 things it can do. It can be off, it can turn on the green light, it can turn on this motor, or it could turn on this motor. And what it does is going to depend on where I turn this switch. Okay. The circuit board is a really complicated version of this. Imagine this, but with 30 or 40 different things it could do. That's the power of the circuit board. We can tell our computer, we can tell our system to do lots of possible different things. And we can do it very quickly. And that's what we're going to do here. The power of the circuit board is going to allow us to turn the platform exactly as much as we want, exactly as fast as we need it to. And that's very powerful for our project. I've taken the circuit board and I've plugged it into the computer, and I've also plugged it into power. This is a power supply. I could also use batteries if I wanted to. I've also plugged in this little blue step motor. Now in my program, it calls the step motor a servo, which is the same thing. Generally, it's the same thing. So let's look at the program, and I'm going to tell you what all these things do. This is me communicating to the circuit board. So I tell it, include servo. I'm telling the circuit board there's going to be a servo involved. Not only that, I've given it a name. I've called it blue servo. Here it is. I have told the computer that I have plugged in the servo to port A0. That's what that's there for. The circuit board has names for all of the ports that are plugged in. So I can plug lots of things in. And I've plugged in this step motor into A0. Okay, and then the program starts. What the program does is when I turn it on, it's going to turn the motor a little bit to the right and a little bit to the left, and back and forth and back and forth and back and forth. So I'm going to press go on the computer, and hopefully, if I did everything right, that's what's going to happen. So let's do it. You'll probably hear it before you see it. Can you hear that? Let me zoom in. It's going to be really hard to see. So it's spinning a little bit to the right and a little bit to the left, back and forth and back and forth and back and forth. Remember, the benefit of the step motor is we can turn our motor little bits at a time, little steps, in order to accomplish what we want to accomplish, and that's what's happening. You can even see the gears turning inside. That's pretty cool. I do know it's hard to see. All right, so the question is, what are we going to do for our main platform? Well, because the platform has to spin a little bit at a time in order for the camera to take pictures of every side of our object, then we need to have this servo, or our servo, we need to have our step motor turn little bits at a time. Well, a full circle is 360 degrees. Okay, just like that. And we need our object to turn a total of 360 degrees. So let's write some more code in here. Let me... All right, so I've updated my program to include more turns, more steps. Here we go. I'm going to send it. Hee hee hee. Isn't that cool? So imagine this step motor lives under the platform, and as the motor turns in steps, it turns the platform on the photogrammetry apparatus. That's the power of the motor. I just wanted to tell you, how thankful I am for everybody and anybody who's watching. And I wanted to tell you how great I feel doing this. It feels right. It feels like this matters. And I hope you feel that way too. Next time we see each other, we may keep working on this project. We might work on a different project. We'll just have to wait and see and find out together. But I wanted to remind you to live the curious life. I'll see you next time.